Okay, for notes 21, we are going to start solving systems of equations, specifically using a method called substitution. So first of all, what is a system? A system of equations is two or more equations, and you are looking for a single or possibly multiple points where they intersect. So this is a line, and this is a line. The idea, and this is not to represent these specific values, okay, but the idea would be if you were to graph these, and I am totally making up lines here, okay? You have one line that does this, you have another line that does this. The solution to the system is the single point, it's going to be an ordered pair, where these two lines cross. That one point makes this equation true, and that one point makes this equation true. So you're looking for the places where both of these equations are true at the same time. Now, I am not saying at all that those represent these two lines. This is just what we are solving for. So I'm actually going to delete this, not to be confused, okay? So here's the thing. Could we graph this? Yes. But we're going to instead use something called substitution. Now, mathematicians tend to be descriptive about naming things. The reason this is called substitution is because we are going to substitute one of these equations into the other. Now, what you may notice here is this equation right here. This equation says x is equal to 3y minus 5. That is what x is. So in the first equation where I have x, I am going to replace it. So instead of 3x, I am going to write what x is equal to. And that was 3y minus 10. I can read, I promise. So then I'm just going to write the rest of this equation. Okay, just the way it's written. So plus 2y equals 3. Now, here's the cool part about substitution. If you do it correctly, the equation that you create will only have one variable in it. Now, you might be looking at, wait a minute, there's two y's there. Yes, I know it's two y's, but both of the y's are the same variable, which means we can now solve this. All right, so I am going to solve this equation as I would anything. So multiplying, a little distributive property here, it's going to be minus 30 plus 2y equals 3. Okay, so 9y plus 2y, they're on the same side, just 11y as is. Okay, so that's going to equal negative 30 equals 3. I'm going to add 30 to both sides, just solving an equation like you would normally. So 11y equals 33, dividing both sides by 11. And after all this hard work, I'm going to get y equals 3, which is fine, dandy, and fabulous, but only half of the answer. Remember, the answer to this system, is the ordered pair that makes both of these equations true at the same time. And while I've now figured out that y is equal to 3, my ordered pair is missing an x value. So that's what I need to figure out next. I'm going to take y, whatever we found for y, in this case 3, and substitute it back into one of the original equations. Does it matter which one? No. But in the case of this problem, I'm going to find this to be the easier substitution. So going back to x is equal to 3. Now, instead of y, I'm going to replace that with a 3, and then minus 10, and I'm going to simplify from there to figure out what x equals. So x equals, 3 times 3 is 9, minus 10, x equals negative 1. So the solution to that system is the ordered pair negative 1, 3. So if I were to put these two values for x and y into this equation, I would get a true statement. And if I put these two values into this equation, it would create a true statement. That is the solution. That is how you solve with substitution. So question number 1, part A is all done. I'm going to slide on over to part B here, and we're going to do the same thing. Now, substitution is great when you have one equation solved for a variable. So where this shows me y equals 16 minus 3x, okay, cool. That's what I'm going to replace y with. So x plus 2 instead of y, I'm going to leave that space to replace it, equals 12. So x is x plus 2y, we'll replace y, equals 12. All right, so y is equal to 16 minus 3x. Again, if I do a quick look at this equation I've just written, there's only x's in this problem, which means I can solve this doing whatever methods I would normally use to solve. So x plus, let's see, 2 times 16 is 32. Negative 6x equals 12. Let's see, negative x minus 6x is negative 5x plus 32 equals 12. I'm going to subtract 32 from both sides. Negative 5x is equal to negative 20. Dividing by negative 5 on both sides. After all this hard work, we're going to get x equals 4, which is great, fine, dandy, wonderful, but not your full solution. Okay, remember, you have now 1/2 of the ordered pair. In this case, it's the 4 for x, but we still need to know what y equals. Now, could you use this x in the first equation? Sure. Could you use this x in the second equation? Absolutely. It doesn't matter. Pick the one that makes you happier. It really. So let's go with y is equal to 16 minus 3 times, leave myself space here for x, which is 4. So y equals 16 minus 3 times 4 is 12, and 16 minus 12 is 4. So when x is equal to 4 and y is equal to 4, so the 0.44, we have a true statement here for both of our equations, which makes that the solution. All right, I believe there is a part C here. There is a part C. So let's continue this doing elimination. I'm sorry, no, this is substitution. Elimination is going to be a future method for us. So, all right, I'm a visual person, so I'm going to highlight what y equals. I'm going to remind myself where y goes, and the rest of the equation, I'm just going to leave it. 3x minus 2, leave my space for the y, equals 12. So 2x minus 8. So if I do a quick double check, right, 3x, minus 2y, minus 2, y is equal to 2x minus 8, equals 12, equals 12. All right. Now I get to solve. All right, so 3x minus 4x plus 16 is equal to 12. So let's see, 3x minus 4x would be negative 1x plus 16. There's a 12. All right, so subtracting 16 from both sides. Let's see, negative 1x equals negative 4. Divide both sides by negative 1. X is equal to positive 4. All right. So there is our positive 4 for x. And as with any substitution problem, I shouldn't say just substitution, with any system, I want to make sure that I am completely solving it, which means not just solving for x, you do need to solve for y as well. So y is equal to 2, leave my space for x. Let's see, I'll replace x with the 4 that we figured out. So 2 times 4 makes 8. 8 minus 8 is 0. So y is equal to 0. It is okay for y to be equal to 0. There's nothing wrong with that. You could, of course, have a point that intersects anywhere on your coordinate grid. This one just happens to be on the x-axis at the 0.40. All right, I'm going to go ahead and cut the video here. So this was all about solving systems of equations using substitution. As always, let me know if you have any questions or concerns, and I'll see you in the next one.